All right, get ready because today we are going deep into transformers.
Deep, deep dive.
You want to know how they work, not just for language, but for like vision models too, right?
Right.
We gotcha.
Yeah.
So we've been checking out this post by Rebecca Lai, From Text Transformer to Vision Transformer Model.
Oh, it's a great post.
It's a good one, yeah.
It's a really good primer on this whole topic.
Yeah, for sure.
Yeah.
So Transformers, they're changing the AI game like big time. So by the end of this deep dive, you'll know exactly why.
Yeah.
Okay, so let's start with the basics.
Okay.
What are Transformers? Why are they so important in AI?
So at their core, transformers are AI models that use attention mechanisms,
Okay,
and that's how they process information.
gotcha.
So they can analyze this information in parallel,
Okay.
which is different from how older models had to process things step by step.
So it's not like word by word, it's like they're taking in the whole sentence at once.
Exactly, yeah.
Okay.
Like it's parallel processing, so it makes them super fast and efficient.
Yeah.
But more importantly, it lets them understand the context of information way better.
Okay,
Way, way better.
that makes sense.
Yeah.
So Rebecca Lai starts with text transformers.
Right.
But before we get to the fancy stuff,
Yeah.
how does a machine even understand a sentence? Like it's not reading along with us, right?
No, it's all about representing text in a way that the machine can actually understand.
Oh, wait, numbers.
Numbers, okay.
So think of it like this. Each word is transformed into a vector,
Okay.
which is basically a list of numbers that represents the meaning.
Okay, so instead of cat being like the word, it's like a series of numbers that represents catness.
Yeah, you got it.
Okay.
You got it. And these vectors exist in kind of a meaning space.
Like a space of meaning.
Yeah, so words that have similar meanings are closer together,
Right.
and words that have different meanings are further apart.
That's so clever.
Right.
That's so cool.
Yeah.
So like cat and dog would be like closer together, but cat and like, I don't know, bulldozer would be like miles apart. Right, exactly.
In this meaning space.
Yeah.
Okay, so what about like word order, though? If it's like seeing all these words at once, how does it know what comes first?
Yeah, that's a great point, right?
Yeah.
Word order is so important to understanding a sentence, and transformers need a way to figure that out.
They need to know the order.
They need to know the order, and that's where positional encoding comes in.
Additional encoding, okay.
A little technical, but each word gets tagged with a unique code
Right.
that indicates its position.
Oh, so it's like a little, like an address, like each word has its own address.
Exactly.
Okay.
Like a little address label.
Gotcha.
And this is where it gets interesting,
Okay.
because Rebecca Lai uses those two sentences.
Yeah.
The cat lies on the sofa, and the sofa lies on the cat.
Same words, completely different meaning. Like,
Right.
I need to know which one's which.
Right, exactly.
Without word order, the transformer might think they're the same.
Totally.
Yeah.
Yeah, positional encoding prevents that by saying, hey, the cat being on the sofa is very different from the sofa being on the cat.
Yeah, very different.
Very different.
Okay, so now it has like the words, it knows the order, it understands how those words relate to each other
Right,
in terms of meaning.
right.
So that's already a lot.
Yeah.
So how does it like do something with this information?
So that's where the magic of transformers really comes in.
Okay.
The attention mechanism.
Attention.
Yeah, it's how the model figures out which parts of the input
Okay.
are the most important to focus on.
So it's like reading a mystery novel and you pay more attention to like the clues that are going to help you solve the case.
Exactly. It's like an inner detective figuring out which words are the key clues.
Gotcha.
That's what allows transformers to reach that deeper level of understanding.
Okay.
Yeah.
And Rebecca Lee has a whole other blog post dedicated to just attention,
Right. Yeah.
if you want to learn more.
If you want to go deeper on that.
But I think we got the basics. We have the basic transformer architecture,
But there are variations depending on what you're trying to do,
right?
what the task is.
Okay.
And Rebecca Lai provides a great table comparing some of the big names in the transformer world.
The big names,
The big names, yeah.
like BERT, GPT, Lamo.
Right. And you can see how they each kind of build upon that core architecture.
That's so cool.
Yeah.
So, okay, so far we've learned that text transformers can take a sentence, break it down,
Yeah.
understand the order of the words, figure out which words are the most important.
Right.
It's almost like they're thinking.
Right. Yeah.
But this is just the beginning, right?
It's just the beginning.
Because then we've got to apply all these principles to images.
To pictures.
Yeah,
eh?
and that's where things get really mind-blowing.
Yeah, it is mind-blowing.
Because how do you teach a computer to see?
Yeah,
There's a whole other thing.
that is a whole other thing.
And that's what vision transformers are about, right?
Exactly.
Okay, so that's what we're going to explore next.
So stay tuned.
Stay with us.
All right, so we've talked about how transformers kind of revolutionize the way AI understands and generates text.
Yeah.
But now let's get into how those same principles can be applied to images.
Yeah.
That's where things get really, really interesting.
It is fascinating, right? How a model that's designed for language
Yeah.
can grasp something as complex as an image.
Yeah, like how do you teach a computer to see?
Right.
That's a whole other thing.
Yeah.
So how do we make that leap from words to images?
Well, it all boils down to understanding that transformers are all about recognizing relationships
Okay.
between individual pieces of information.
Okay.
So in text, those pieces are words.
Right.
But when it comes to images, they become image patches.
Image patches. Okay, so are we literally like chopping up the image into squares?
We are. Yeah.
Okay.
Yeah. So vision transformers, or VT,
ITs. Okay.
they work by dividing an image into these smaller patches.
Right.
Kind of like creating a mosaic.
And each patch is then treated as its own unit of information, just like a word in a sentence.
Okay, so instead of looking at the entire picture at once, it's analyzing these little pieces individually.
Exactly, yeah.
Gotcha.
So each patch is then flattened into a vector,
Right.
similar to what we discussed with text embeddings.
Okay.
So it gives the model a numerical representation of each piece of the image
Yeah.
ready for processing.
Okay, I'm starting to see the connection back to text.
Yeah,
But images aren't just like a jumble of patches, right? Like they have a structure,
right.
layout.
Absolutely.
How does the model keep track of where each patch fits in the bigger picture?
Yeah, that's where positional encoding comes back into play.
It's back.
It's back.
Okay.
Yeah, just like with text.
Okay.
It's crucial for VITs to understand the spatial relationships between those patches.
Right.
So if the model doesn't know where each patch sits in the original image,
Yeah.
it's like trying to solve a jigsaw puzzle with no picture for reference.
Oh, yeah, that would be rough.
Yeah, exactly.
Okay. So it's like giving each patch coordinates.
Exactly.
Like, hey, you go here, you go there.
This is your spot.
Okay.
Exactly.
So this positional encoding ensures that the VIT doesn't lose sight of the overall picture
Right.
of the structure.
To structure, yeah.
Okay, and now here comes the really cool part.
Right.
So VITs utilize the same self-attention mechanism we discussed with text transformers,
Right.
but they apply it to these image patches.
Right.
So this means each patch is being compared to every other patch in the image,
Yeah.
allowing the model to capture relationships and patterns across the entire scene.
Wow. That's a lot of comparisons.
It is, yeah.
It's like the VIT is looking at the whole forest
Right.
and every single tree at the same time.
Exactly.
That's different from CNNs, right?
Yes, it is.
Convolutional neural networks. They usually analyze a small area of the image at a time, right?
They do, like focusing on individual trees. Right, and this is looking at everything.
Exactly, yeah.
It has this global understanding.
Global understanding. Yeah, that's one of the big advantages.
That sounds like a huge advantage.
Yeah. Yeah, it is.
Okay, so can you give me an example of how that makes a difference, like in the real world?
Yeah, so imagine a self-driving car using a VTID.
Okay.
It can not only detect a pedestrian crossing the street,
Right.
but also understand their direction and speed
Wow.
relative to other cars and traffic signals.
Okay.
So this leads to safer navigation.
So it's like giving the car a superpower, right?
Yeah.
Like it can see everything, understand everything,
Exactly.
make decisions.
Yeah, yeah.
Okay, so now, before we move on to applications, let's revisit that QKV concept.
Right.
Query, key, and value.
Yes.
I have to admit, I'm still a little fuzzy on that,
Okay.
how that actually works within the attention mechanism.
It is a bit abstract,
Yeah.
but think of it like searching on Google.
Oh,
You type in a query, right?
like that's your question.
That's your question.
Right.
Okay. And the keys are like the keywords on various web pages
Okay.
that help you narrow down your search.
Right.
And then the values are the actual content on those pages
Okay.
that provide the information you're looking for.
So the attention mechanism in a VT
Yeah.
is like helping it find the most relevant web pages.
Exactly.
But in this case, image patches
image patches.
to answer its query
Yes,
about a specific part of the image.
you got it.
Okay, that makes a lot more sense. So it's like actively seeking out the information it needs
Right.
to understand the image as a whole.
Exactly.
Okay, so now we've got the model, analyzing the image, understanding relationships, asking questions.
Right.
But what can we actually do with all of this power?
Right.
How are VTs making a real-world impact?
Ah, that's the exciting part.
Yeah.
So we're talking real game changers in fields like object detection,
Okay.
medical imaging,
Okay.
and image classification.
Right.
And we're really just beginning to tap into their potential.
So hit me with those aha moments.
Yep.
What are some real-world applications that are already making waves?
Okay, let's start with object detection, which is so important
Yeah.
for things like self-driving cars.
Self-driving cars, right?
Oh.
That was our example earlier.
Yeah, so VITs are really good at this because they can analyze an entire scene
Right.
and accurately pinpoint the location of objects,
Okay.
like helping those cars navigate safely.
Okay, so yeah. It's like giving the car a superpower.
Exactly.
Okay.
And it's not just self-driving cars, right?
Yeah. Where else?
Object detection is revolutionizing everything,
Okay.
from security systems to retail analytics.
So it's automating and refining a lot of the processes
Right.
that we have that use visuals.
Exactly.
Okay, what about medical imaging? I feel like there's a lot of potential there.
Huge potential, yeah.
Yeah.
So imagine being able to detect minuscule tumors in a scan that a human eye might miss.
Oh, wow.
Or analyzing complex medical images to diagnose diseases earlier and more accurately.
Okay.
VITs are already making strides in these areas,
Wow.
leading to potentially life-saving advancements.
It's like giving doctors superhuman vision.
Absolutely.
Okay.
Yeah.
And then there's image classification.
Right.
Which is basically like sorting images into different categories.
Exactly.
Right.
And this has applications in everything.
Okay.
From managing photo libraries to identifying different plant and animal species.
So basically, anywhere we need to make sense of a lot of visual data,
Right.
VITs can step in and help us do it faster and more accurately.
Yeah,
It's amazing how quickly this technology is evolving.
it is. Yeah.
It's mind-blowing.
Yeah.
We went from analyzing text to changing how we perceive and understand the world around us.
Yeah, it's a huge shift.
It's a big deal.
Yeah.
Okay, so we've talked about self-driving cars, medical imaging.
Right.
Where else could this lead us? What other areas are ripe for disruption?
Oh, tons of areas.
Okay,
Well, let's think about urban planning, for example.
urban planning. Okay.
So imagine a VIT analyzing aerial images of a city
Okay.
to identify areas that are prone to traffic congestion or pollution.
Oh, wow.
So those insights could help planners design more efficient and sustainable urban
So
environments.
that's a really cool application.
Right.
Yeah.
And what about environmental monitoring?
Okay.
So VITs could analyze satellite imagery to track deforestation
Okay.
or the melting of glaciers,
Right.
providing vital data for climate change research.
So it's like, yeah, being able to analyze so much visual data
Right?
in such a like deep way
Yeah,
opens up so many possibilities.
it does.
It's like giving AI a new set of eyes.
It is, yeah. Right.
The eyes that can perceive things we can't
Right.
and process information in ways we never thought possible.
Exactly.
It truly is remarkable.
It is, yeah.
This advancement in AI,
Mm-hmm.
but this incredible power also raises some interesting questions, doesn't it?
It does.
Like, what happens when AI can see the world better than we can? How does that change our relationship with technology?
Those are huge questions.
The big questions
Yeah, we need to consider.
as this technology keeps evolving.
Absolutely. It's
Yeah.
not just about the technical leaps.
Right.
It's also about the human element.
Right.
And how we integrate this technology responsibly and ethically into our lives.
Well said.
It's a challenge,
It is.
for sure,
Yeah.
but one that we need to face
Yeah,
completely
absolutely.
head on.
Head on.
Well, I think we've covered a lot of ground today,
We have.
from the fundamentals of transformers to the potential of VTs.
Yeah.
I feel like my eyes have been opened. I've
It's
learned a
great.
lot.
That's good to hear.
You know, it's amazing to think about how far AI has come, like even in a short time.
Yeah.
We've gone from, like basic image recognition to models that can really truly understand
Right.
the whole context of a scene.
Full scene. Yeah.
It's pretty wild.
It is.
And this shift from, local to global understanding.
I mean, that's what has the potential to like completely change so many fields.
Oh, yeah,
Right.
for sure.
We've already talked about self-driving cars and medical imaging,
Hmm.
but thinking about the broader applications of VTs,
Right.
that's where things get really interesting.
Yeah.
Right.
Totally.
Where-
What else is out there?
Well, I mean, imagine
Yeah.
imagine using a VT to analyze historical documents
Historical documents.
or artwork.
Okay.
It could help us uncover hidden patterns or details that like the human eye just misses,
Right.
potentially leading to, new historical discoveries
Wow.
or a deeper understanding of artistic techniques.
It's like giving historians and art enthusiasts a whole new lens
Right, exactly.
to view things.
Yeah.
That's amazing.
Yeah, and I mean that's just one example.
Yeah.
The potential applications of VATs.
Yeah.
I mean, they're truly vast and
It-
span like countless industries.
It's clear that AI is no longer just about like crunching numbers.
Or following, pre-programmed rules.
Right.
It's about understanding,
Yeah.
interpreting,
Yeah.
even interacting with the world
Right.
in ways that we thought were like only human,
Yeah. I mean, we're really witnessing a fundamental shift
Yeah.
in the capabilities of AI.
For sure.
And it's exciting to think about like what that means for the future.
Yeah, I think one of the biggest takeaways from this whole deep dive today
Yeah.
is just how powerful transformers are.
Right.
Like their ability to understand context, whether it's language or images. I mean, that's what sets them apart.
Right.
And that's what's led to these like huge advancements.
Exactly.
Right.
Yeah.
It's remarkable.
It is. Yeah.
So this ability to see relationships across an entire image, to grasp the big picture, but also pay attention to the finer details.
Yeah.
That's what makes VITs so unique
Right.
and so impactful.
Totally.
It's like they're giving machines a new way of seeing the world, a way that's more aligned with how we see things.
Right. How humans perceive and understand things.
Exactly.
Yeah.
And as this technology keeps evolving,
Right.
I mean, it's bound to have a huge impact on our lives.
Oh, yeah.
I mean, in ways we can't even imagine right now.
Yeah, for sure.
Like, I'm walking away from this feeling very inspired
Good.
and maybe a little mind blown, to be honest.
That's mind-blowing stuff.
Yeah, because it's clear that what we've talked about today is really just the beginning,
The tip of the iceberg.
the tip of the iceberg.
Yeah.
So what do you think? Where do we go from here?
Well, I mean, think about it.
Yeah.
Think about how this technology could change your own field of work.
Okay. Yeah.
What problems could it help you solve?
Right.
What new opportunities could it unlock?
That's a really great question for our listeners to think about.
Yeah, the future of AI is
Yeah.
it's brimming with potential.
It really is.
Yeah. And VITs are, I mean, they're really leading the charge here.
They are leading the way.
Yeah, for sure.
Okay, well, listeners,
Yeah.
thank you so much for joining us on this deep dive into the world of Transformers.
Yeah, thanks for listening.
We hope you found it insightful and interesting and thought-provoking.
We hope you learned something.
We hope so.
Yeah.
And, until next time, keep exploring,
Yeah, keep learning.
keep learning, and keep asking questions.
Keep asking questions.
Because the world of AI is so vast and ever-evolving.
it is.
And we can't wait to see what groundbreaking discoveries lie ahead.
Yeah, it's going to be exciting.
It's going to be really exciting.
For sure.